So the first question here says, a mixture of iron and sulfur can be separated by dissolving the mixture in dash. So iron is in solid form, sulfur is in solid form. So how can you separate the mixture? So you have to use at least a medium in which one of them will dissolve in. So let's check the options one by one. So we have benzene here. Benzene cannot dissolve iron and it cannot dissolve sulfur. It only dissolves sulfur partially. So if it dissolves sulfur partially, that means some amount of sulfur will still remain undissolved and it will be very hard for you to separate it from the iron. So benzene is not the answer. Okay, so let's move to the next one. The next one is dilute hydroxide, sodium hydroxide. So it's going to dissolve iron partially too, but there will be some iron that will be undissolved. Next one is dilute hydrochloric acid. So HCl will dissolve iron completely. So that means iron will now be in aqueous form, while the sulfur will be in solid form. Then you can now use filtration method to separate it or to separate them. So iron reacts with steam, but the end result will be a solid compound. So you are still going back to the same solid, which will be very difficult for you to separate from sulfur. So the only answer there is dilute hydrochloric acid. So the answer is option B. Okay. 7.5 gram of oxide of lead was reduced to 61.2 gram of metal. I had to calculate the formula of the oxide. So they gave you the mass of the metal, which is Pb. So Pb is 61.2 grams. Then the mass of oxygen there will be 67.5 minus 61.2. That will give you 6.3. So that means oxygen is 6.3. So the next step, divide by the relative atomic masses. So this one will be over 16, while lead will be 207. As you can see there, the relative atomic mass of lead is given 207, oxygen is 16. So let's divide this real quick. So this one gives us 0.2957. 6.3 divided by 16, 0.39375. So we divide by the smallest one. The smallest one is 0.2957. So we're going to divide by that. So the whole division, this one gives you 1 here. This one gives you 1.33. So 1.33 can be written as 4/3. So you can write this as 1 here and this one as 4/3. So that means you have to times all through. But this one is a fraction, so you have to times all through by 3. So 3 times 1 here will give us 3. 4/3 times 3 will give us 4. As in 4/3 times 3. If you cut it, you're going to get 4. So that means the one for Pb is 3 at the bottom, then oxygen will be 4. So that will be Pb3O4. So you can check that out. So you can see that's option C. Okay. So for the next one, calculate the minimum volume of the oxygen that is required for complete combustion of a mixture of 20 cm³ of CO and 10 cm³ of hydrogen. So it's a mixture of CO, which is carbon dioxide, mixed with hydrogen. So we're looking for the amount of O2 that will be used to burn both of them. So we're going to do a reaction between CO and oxygen, then between hydrogen and oxygen. So if you write that reaction between CO and oxygen, you're going to get something like this. So you have CO plus O2. This one will give us CO2. So this is the first reaction here. So to balance it up, you just put 2 here, then you put another 2 here. So it is balanced now. So the ratio is 2:1. So 2:1 because there's nothing here, so that is 1. Then since the ratio is 2:1, in terms of the volume of CO that was given to us is 20 cm³. So this one will now become 20. Then what would this one be? So if you cross multiply and just solve this, you're going to get 2x equals to 20. So from here you get x as 10. So that means you need 10 cm³ of oxygen. That's what you need in terms of the CO. Okay. The next one is to write another reaction between oxygen and hydrogen. So let's do that one. But the volume of hydrogen that will be given is 10. So let's write that one first there. So you have H2 plus O2. This one will give us H2O normal. So balance it up. We're going to write 2 here, and I'm going to put on that 2 here. So you can see that the ratio is still 2:1 too. But the volume of H2 that was given to us is 10. So you don't know what oxygen will be. So I'm going to put x here. So just cross multiply and solve this. You're going to get 2x equals to 10. Then from here, you get x as 5 cm³ of oxygen. So that means you need 5 cm cube of oxygen for the hydrogen and 10 cm cube for the carbon dioxide. So 10 plus 5 will give us 15. So that means you need 15 cm cube in total for the whole combustion process. So if you check it out, you see that's option C. Okay. For the next one, HNO3 plus H2O, okay, engaging in a reversible reaction gives us H3O plus NO3 minus. So in this reaction above, NO3 minus is the dash. So they give us this option here. So we have to check if this NO3 minus is the conjugate acid or if it's a conjugate base. So how do you form the conjugate base? Now, conjugate base is formed from the acid. So anytime the acid loses a proton, then what you're going to get is conjugate base. Let me do an example for you. Look at this acid here. You have HCl as an acid, right? So we're going to remove one H. That means this H is losing a proton. By the time you remove this H, you're going to have Cl minus only. So this Cl minus is the conjugate base of this acid. You understand? Another one is H2SO4. H2SO4. This H2SO4 is sulfuric acid. Okay, so I'm going to remove one H now. If I remove one H, it's going to be HSO4 minus. This HSO4 minus is the conjugate base of this acid. You understand? So that's how you form conjugate base. Then the next one is conjugate acid. To form conjugate acid, you need to add H plus to the base. So if you have NH3, which is in basic form, you have to add H plus to it, and this one will give us NH4 plus. So NH4 plus is the conjugate acid of this base NH3. So you can see for conjugate base, you need to remove H plus, remove one proton. Then for conjugate acid, you need to add H plus. So go to the question back now. So you look at the question now, this is HNO3 here, and this is NO3. So you can see that the H has been removed. So since the H has been removed, then that means NO3 minus is a conjugate base. Okay, it's a conjugate base. So the answer is option C. The pH range of neutralization products of CH3COH and KOH is dash. So CH3COH is acetic acid or ethanoic acid, while KOH is potassium hydroxide. So this one is a strong base, this one is a weak acid. So when you combine a weak acid and a strong base, the base will have more power. So the pH will be close to, towards the ending part, towards 14, towards 13. Okay, because 7 is neutral. So for you to have 1 to 3, that means you must have a strong acid, and there's no strong acid here. So option A is not the answer. This one cannot be the answer. So this one is saying that it is kind of neutral. 7 to 8 is kind of neutral. Then 6 to 7 is weakly acidic and getting close to neutral. So this cannot be the answer. You need something that is basic. So for it to be very, very basic, it needs to be like 12, 13, 14. So the answer is option D. So the answer is option D because we're using a strong base and a weak acid. Okay, next one. How much NaOH is required to make 250 cm cube of 0.1 mole per dm cube solution? So this is under concentration. Formula to find concentration is N equals to CV. So this N here is the number of moles. This C here is the concentration in mole per dm cube, while this V is the volume in dm cube. So check what they give to you. You're looking for how much. So that means our answer should be in grams. So they give us 250 cm cube, but it needs to be in dm cube. So we're going to divide it by 1000. So that will give us 250 divided by 1000. So that will give us 0.25. Okay, so the number of moles that we need is the concentration now, which is 0.1. So 0.1 times then V, the volume, that will be 0.25. So if we times this, we're going to get 0.025 moles. So this is not the answer. The answer should be in grams. So we need to convert this answer to grams using number of moles equals to mass over molar mass. Okay. Now for this molar mass of NaOH will be given by Na is 23 plus oxygen is 16, hydrogen is 1. So 23 plus 16 plus 1 give us 40 grams per mole. So everything is 40. So bring it back here. This your N is still this answer that is here. So you write 0.025 is equals to mass. It's mass you're looking for. over molar mass, we got 40. So our answer should be 0.025 when you cross multiply times 40. So what are you going to get when you do 0.025 times 40? So that will give you 1 grams as the answer. So the answer is 1 grams. So let's check. So you can see there, that's option B, 1 grams. For number 7, 2PbO2 produces 2PbO plus O2. In the above reaction, you have to find the oxidizing agent. Now, the oxidizing agent is the one that the oxidation number is reduced. Okay, so that's what we're going to check here. Anyone that the oxidation number has reduced, that will be the oxidizing agent. So they give us PbO2. We need to find the oxidation number of lead here first. So let it be X. This one will be X plus the oxidation number of oxygen is -2. So we're going to write 2 into -2, equate everything to 0. So this will give you X plus 4 is equals to 0. Sorry. So this will give you X minus 4 is equals to 0. Then from there, X is equals to plus 4. That means the oxidation state of lead in this first part, in this part here, is plus 4. Okay, lead is plus 4 here. Then let's check for it here. If you check for it here, you will notice that the formula is PbO. That means it is balanced. Oxygen is 2 normally. Then this one too has to be 2. This one will be plus 2. This one will be minus 2 for it to be balanced. And you can see that it does not have any charge at the top. So for it to be balanced, oxygen is -2. This one too has to be 2. So that means it dropped from plus 4 to 2. So that means Pb4 plus, this option A, is the answer because it dropped from plus 4 to 2. That means it's reduced. Anyone that is reduced is the oxidizing agent. Take note of that. Any species that is reduced, that means it is the oxidizing agent. So that means option A is the answer. So Pb4 plus change to Pb2 plus. So Pb4 plus is the answer. That is the oxidizing agent. For number 8, a current of 0.5 amperes flows for 1930 seconds and deposits 0.325 grams of metal M. If the charge is plus 2, we have to find the relative molecular mass. Okay, so there's a formula. This is under electrolysis. Okay, electrolysis. This is the topic, electrolysis. So they're going to use the formula M is equals to MIT, MIT divided by CF. Very short and straightforward formula to give you the answer fast. So the M here is the mass. Where is the mass? This is the mass here. This capital M here is relative molecular mass, which is what we're looking for. This I here is the current. This is the current here, 0.5. This T here is the time. Where is the time? 1930 seconds. This C here is the charge. Where is the charge? Plus 2. Why this F here is the Faraday constant, okay, which is 19,500 coulombs. So plug everything there. You're going to get, so make capital M, so the formula. So that will give you M, capital M is equals to small m CF divided by IT. So plug everything there. Our small m is 0.325. So you have 0.325 times our charge, which is C. We're going to get 2. Faraday constant, that's 96,500. Divide everything by the current there is 0.5 amperes and the time is 1930. So 0.5 times 1930. So if you times everything at the top, you're going to get 62725 divided by then 0.5 times 1930. You're going to get 965. So just divide this. That'll give you 65. Okay, 65. So check it in the option there. So you can see that's option A, 65. So the answer is option A. The next one, emission of CFC, which stands for chlorofluorocarbon, into the atmosphere causes what? So CFCs are organic compounds, okay, and the major thing that they do in the stratosphere is that they deplete the ozone layer. The ozone layer is like a covering, okay, that protects the earth from the harmful ultraviolet rays of the sun. So CFCs, they deplete the ozone layer. Okay, so that's option C. The next one, we are given this diagram here, and we have to, so in the diagram above shows the reaction parts of an exothermic reaction. The heat of the reaction is what? Now, heat of reaction is a heat that must be evolved for a reaction to take place. Okay, the amount of heat that is needed for that reaction to take place. So it is always given by the formula heat of the product, or the enthalpy of the product minus enthalpy of the reactant. So it's a state parameter because it depends on the product and the reactant. So we're going to do product minus reactants. So let's check the energy of the product. The energy of the product is given by this line here, which is this side here, this particular point. Then energy of reactant is given by this side. So we need the distance from this point 1 to point 2. If you check that, that is option 4. Okay, so check it out there. That's option 4. That will give you the answer you need. Next one, which of the following samples will react fastest with dilute HCl? So 10 gram of lumps of CaCO3 at 25 degrees C, 10 gram of powdered CaCO3 at 25 degrees C, and so on like that. This topic is under rate of reaction. So rate of reaction is always affected by what is called surface area. If a particular material is in powdered form, then it will be able to react very, very fast. Okay, and if the temperature is also high, it also reacts very, very fast. But if it's in lumps, like it is big size, it will be very hard for it to, as in it's very hard for it to react very fast. But if it's in powdered form, the reaction will take place very fast because the large surface area will be exposed for reaction. Now, check the options very well. Lumps of material means it is in big or thick solid form, and temperature is also low, so A cannot be the answer. To make it fast, powdered form should be what we are looking for, and a high temperature. So powdered form, we have seen it here, and high temperature. Be careful of this option. It is not the answer because you have powdered form and a lower temperature of 25 degrees C. So the answer there is powdered form of CaCO3 and a temperature of 50 degrees C. That will make the reaction to occur very fast. So the answer is option D. The color exhibited by copper in a flame test is given by dash. Now, flame test is a kind of test that is used to test the color given off by different compounds when they are ignited. Okay. Now, these colors are given off because of the electrons that are excited from one level to another. So when these electrons fall back, they give up different wavelengths of light, which can be seen. Now, to get this answer correctly, we need to check which elements will give off these colors when they are ignited or when they are burnt. So the first one there is crimson color. Crimson color is for lithium. Okay, blue-green color is for copper. Lilac is for potassium. Okay, white green color is for barium. Okay, so keep that in mind. So the correct answer to this question is blue-green color. Okay, that is for copper. So the answer is option C. Option C is the answer. The next one, which of the following statement is correct? So we have chlorine bleaches by oxidation, chlorine bleaches by reduction, sulfur bleaches by oxidation, and so on. Chlorine bleaches by oxidation because chlorine is an oxidizing agent. Most of the time, it acts like an oxidizing agent. Whereas for forq acts as a reducing agent. Okay, so chlorine bleaches by oxidation. Why? So for forq bleaches by reduction. So if you check the answer, you will see the answer there, which is option A. Okay. The IUPAC name for this compound is what? Now look at this question very well. Be careful. The IUPAC name for this compound is what? So you need to check the ring that you have. This is a benzene ring. Okay, this is a benzene ring. This ring here is a benzene ring. Then the functional group there is COH, which is more important or more stronger than the Cl. So the number we start from here 1, 2, 3, 4, and 5, and 6, and so on like that. So this compound, to name this compound will be 4-chlorobenzoic acid. That's how you call it. Benzoic because you have the functional group for alkanoic acids there. So this is 4-chlorobenzoic acid. But if you check the option, it is not there. Now, that's because another name for 4-chlorobenzoic acid is p-chlorobenzoic acid. This is another name for it. P-chlorobenzoic acid. It's another name for 4-chlorobenzoic acid. Why this M-chlorobenzoic acid is another name for 3-chlorobenzoic acid. So this M here stands for meta. So you can say meta-chlorobenzoic acid. Why this P stands for para-chlorobenzoic acid. Okay, keep that in mind. Keep that in mind. So our answer here is option D. Okay, 4-chlorobenzoic acid or p-chlorobenzoic acid, where the P stands for para. For number 15, 3-methyl-butan-2-on is an isomer of dash. Butan-2-on is a ketone. Okay, it's a ketone, or you can say it's an alkanon. And alkanons follow this formula, CnH2NO. This is the formula that they follow. These are general molecular formula. So since it is butan, okay, butan, that is 4. I'm going to put 4 in this formula. So that will be C4H8O. This is the formula we are looking for. Okay. But since we have a 3-methyl there, you can see we have a 3-methyl. That means there's a methyl group that is attached to it. Because there's a methyl that's attached to it, you have to remove one hydrogen from here. This one will now be 7. This guy will now be 7. This one becomes 7. Then you now add everything back together. So C4 plus ordinary C will give you C5. H7 plus H3 will give us H10. Then this will now be O. So we're looking for a compound that has this formula, C5H10O. So come here, I'm looking for C5H10O. This is what I'm looking for. So let's check the options. 2-methyl-prop-1-ene. This is an alkene. It does not have any oxygen. This one cannot be the answer. This one too is also an alkene. It does not have any oxygen. This one too cannot be the answer. This one cannot be the answer. The next one is 3-methyl-pentan-2-on. Now let's check 3-methyl-pentan-2-on. Let's see if the formula will also be C5H10O. Now 3-methyl-pentan-2-on is also a ketone, so you should obey that formula. You should obey CnH2NO. Okay. Now since it is pentan, that means it is 5, Abi. So we're going to put 5 here. That will give us C5. This one will be 10. C5H10O. You can see that they have almost the same formula, but you might rush and go and choose option B. That's not the answer because I have not added the methyl part. So let me add the methyl part now. So there's a 3-methyl there. So just write plus CH3. Since I'm adding a CH3, that means this guy must reduce by 1. So this one will now become 9. This guy will become 9. So that will be H9. Then I'll now add everything back. So this is C5 plus C. That will give me C6. H9 plus H3. That will give me H12. Then this one will give me O. So at the end of the day, I add C6 H12O, which is not the same as C5H10O. So this one is not the answer. Option B is not the answer. So obviously, we're left with only one option. That option definitely must be the answer. Pentanal. This is pentanal here. If you want to confirm it, pentanal is an aldehyde. Okay? Or you can say it is an alkanal. And alkanals have almost the same formula with ketones, which is CnH2NO. Okay, so if you check the formula, you see that pentanal is 5. Pent, that's 5. So put 5 here. That will be C5H10O. The same formula with what we want as our 3-methyl-butan-2-on. So you can see that they have the same formula. And what are isomers? Isomers are just compounds that have the same general molecular formula, but they have different structures. So these two compounds, this one is a functional isomer. This one here is an alkanon. This one here is an alkanal. So that means two of them, they have the same general molecular formula, but they have different structures. Okay, they are called functional isomers. So our answer here is option A. Okay, pentanal. I hope you have gained something from watching this short video. Make sure you subscribe and follow this channel for more videos like this. And check out the next video on your screen, which is going to help you in your chemistry. Remain blessed. Peace.